today we are going to continue with the quadratic formula. So the process and everything, oh dear, I can't write and talk. The process and everything that we were looking at yesterday is going to be exactly the same. We're just gonna deal with now irrational roots. Okay, and that means that when we are solving, we won't get a nice, neat, perfect answer that splits into two integer values, two rational values. Our formula is still the same. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Our process is even still the same. So let's say we have one that we want to solve that says x squared plus 5x minus 1 equals 0. Okay, we have a quadratic because we have an exponent of 2. It's equal to 0, which is what we said we needed to happen. Okay, so just like yesterday, our first step is going to be to find a, b, and c. Remember, a is always what's in front of x squared, and if we don't see anything, that's a 1. B is what's in front of x, so that's going to be a 5. And c is the constant by itself, so that's going to be a negative 1. And we're just going to start plugging this into the quadratic formula. So I'm going to start replacing each letter, right? So negative b. So in this case, I'm going to say negative 5. Plus or minus, right? I'm just going across the formula up here. I'm going to put the square root next. And now instead of saying b squared, right, I'm going to replace b with the number. So 5 squared minus 4, that 4 is part of the formula, times a, which is 1, times c, which is negative 1. All over one big, long fraction bar. 2 times a. In this case, a is 1. Okay, and then just like we said yesterday, we can still just use our calculator to help us solve this. So we are going to take all that stuff underneath the square root and put it into our calculator. Reminder, right, we are only doing what is underneath the square root. Do not type in the square root or anything else. So we're just going to do 5 squared minus 4 times 1 times negative 1. And our calculator tells us 29. Okay, so now we have negative 5 plus or minus, and that number we got underneath the square root for this is 29 all over 2. Now, yesterday, our next step was to simplify the square root of 29. So if I take the square root of 29, sorry guys, there's an announcement.
Sophomores with no English class, trimester 1, may go down to have their pictures taken.
Okay.
Thank you.
So we're just gonna ignore that, making a video of that. So if we take the square root of 29, I'm gonna do second x squared 29 equals, and now I get this big old long decimal, right? That means that this is not a perfect square. I can't take the square root of 29. Okay, and if I can't take, it's not a perfect square, then I need to try and simplify the square root of 29. So now I need to take my square root and I need to try and prime factor it and simplify it. But if we try and think of numbers that will multiply up to 29, we are not going to find any. So if we can't get this simplified and we can't take the square root, we are done. Our answer is just x equals, right? This is really x equals negative 5 plus or minus the square root of 29 all over 2. And that means negative 5 plus the square root of 29 over 2 and negative 5 minus the square root of 29 all over 2, right? We get 2 answers. They just both happen to have square roots in them. Okay, so let's look at another one. Let's say we have 3x squared plus 2x equals 14. So yesterday we said our first step, our first rule is that we need this to equal 0. And this currently does not equal 0. So we need to do some math to make it equal 0. right? And to make it equal 0, we said this yesterday, to move a positive 14, we will subtract 14 from each side. These cancel out and make 0, and now I have 3 things over here. A 3x squared, positive 2x, minus 14, right? 2x and 14 are not like terms, so I cannot combine them. Now I'm equal to 0, and now I can start using the quadratic formula. So A equals 3, B equals 2, C equals negative 14. So we will start plugging into the quadratic formula. So we'll say negative B. So in this case, negative 2. Plus or minus the square root of B squared. So B is, again, 2, so 2 squared. Minus 4 times A, which is 3, times C, which is negative 14, all over 2A. And then again, in our calculator, we're going to type all that stuff underneath the square root into our calculator. So just this stuff right here. Okay, so I'm going to do 2 squared minus 4 times 3 times negative 14. I get 172. Okay, so now I have negative 2 plus or minus the square root of 172. Right, 2 times 3 is 6. So if I take the square root of 172, let's always check that, I get this big old long decimal. Okay, so that means it's not a perfect square, and I need to go back to my square root rules, and I need to try and simplify the square root of 172. And again, whether you're using your calculator, whether you're doing whatever, we just need to prime factor 172. So maybe you choose 2 and 86. 2 and 43. And that's it. 43 won't split up. So 2, 2, 43. Okay, now we're going to look for pairs. So I see a pair of 2s. I'm going to pull that pair out here in front. So I now have 2 square root 43. Okay, so that 2 square root 43 is the same thing as the square root of 172. So I have negative 2 plus or minus 2 square root 43 all over 6. So now we've had a lot of steps, but they're all things that we've done before, so nothing new. This next step isn't new, but it's going to look very new. You have to think all the way back to how we reduce fractions and how we deal when there's non-like terms in fractions. Okay, and that is we're going to look at all of these numbers that are outside of the square root. So I'm not counting that 43. It's inside the square root, so it doesn't count. And I want to see if there's anything that I can divide those all by. Maybe sort of like thinking of a greatest common factor, right? What's a number that we could divide them all by evenly? And we could divide them all by 2. So that's exactly what I'm going to do to reduce them. So I'm going to take negative 2 divided by 2, which gives me a negative 1. 2 divided by 2, which gives me a 1. I could write this 1, but I don't have to. The square root of 43 stays the same. And 6 divided by 2, which is 3. Okay, and this is my answer. But again, remember, this is x equals, and it's actually 2 numbers. Negative 1 plus the square root of 43 over 3, and negative 1 minus the square root of 43 over 3. Okay, we're going to look at one last example here. Let's say we have 8y squared minus 2y plus 22 equals 0. Okay, so this does equal 0, so we're in the correct format. We can start using the quadratic formula. So A equals 8. B equals -2. C equals 22. Okay, so I'm going to start plugging this into the quadratic formula. So I'm going to say the negative of B. Well, B is already negative, right? So we said yesterday, if that's the case, we turn it into a positive. Plus or minus. If B is negative, we have to put it in parentheses when we square it. Minus 4 times A times C all over 2 times A. Okay, so now we have 2 plus or minus, and we're going to put all this stuff underneath the square root in our calculator. So we have to put that in parentheses. Minus 4 times 8 times 22. So we get -700. At this point, nothing else matters, right? We said whether it was step 1 or step 100. As soon as we get a negative underneath the square root, we are turning this into a no real solution, right? We could also write this as NRS, and we are done.